everyone. My name is Jared Evans. I'm the marketing manager for ALS in North America. I want to thank you all for joining us today for Webinar Wednesday. Our presenter today is Les Arnold. Les began working in environmental laboratory in 1978 while operating several small package municipal and industrial wastewater treatment plants. In the 1980s, he moved into the steel industry and worked in the lab as an analyst, wet chem manager, field service manager, project manager, and laboratory manager. Currently, Les is working as a project manager in the Holland, Michigan laboratory with emphasis in the steel industry, inside sales, and assisting the field service team. He is involved in many projects that include low-level mercury sampling and analysis. Today, Les will be presenting some of the common issues we see with the low-level mercury sampling, as well as the various and current sample kits used by various ALS facilities. During the presentation, feel free to ask questions. To do that, use the chat box or ask a question in the question box, or click the raise your hand feature, and we'll pause and call on you. Or read your question, and Les will answer those to the best visibility. Just want to remind everybody that if you go to alsglobal.com and search Webinar Wednesday, you can see recordings of past webinars, you can see a schedule of upcoming webinars, and you can sign up for email alerts to notify you of future Webinar Wednesdays as well. With that, Les, thank you for taking time to deliver the presentation, and I will turn it over to you.
Okay, thanks, Jared, and good afternoon, everybody. Good morning, depending on where you're at. I will have to admit that when they first asked me to do this, I instantly said yes, because I do a lot of, as a project manager, I have a kind of a hybrid position. I prepare bottle kits and do project management, and which includes reporting, but also I help the field crews with various projects, but the low-level mercury sampling is a big part of it, because there's so many obstacles. The consultants and all the people that we send bottle kits out, I watch the kits go out, and I think, well, how would I do? I wonder what's happening when these kits go out. In Holland, we use 40 mil vials, and we'll discuss all this later on, but as these kits are going out, I just think to myself, I wonder what's happening out there. So that said, I want to just kind of touch on the various things that I see and the various things that I've seen. Our field crew basically covers, we have about 20 or so staff covering from Cleveland, Ohio, through Detroit, over to Chicago on a daily basis, and we probably collect maybe a couple hundred low-level mercury samples every month, and then the lab sends out 1,000 sample kits every month, and that's the Holland lab. So that said, let me I'm going to start this off with the video that was prepared. Kind of a basic overview of the method 1669, which is a clean hands, dirty hands, low-level mercury sampling method. And this is a video that was prepared by Jared's team, and this is a kind of a high-level overview of the method. So I'm just going to go ahead and play the video, and we'll get this started.
Hey Les, the audio on the video is not coming through. Is there a way to?
It's not.
Is there a way to put it through to your speakers so your mic will pick it up?
Say that again, Jared.
Is there a way to put it through your computer speakers so that your mic will pick it up?
I could play it via the web. Let's just play it. Let me see. It's not playing the audio at all?
Correct.
Is it? Okay, I'll just narrate it. How's that?
There you go.
All right, so we'll just continue on. One thing I'm going to have to do is unplug my headphones because it's got your voice in the video and it's driving me crazy.
Includes one sampling kit,
okay,
one duplicate
you
kit,
can still hear it in the background, I guess.
field blank kit,
Gloves.
Just
Can
mute
you
it.
hear that, Jared?
Just mute it on your screen.
There's melting pump, Teflon dipper.
Well, anyway, it's going through some of the processes or the things that are included with the kits here. Peristaltic pumps,
Can provide advice and
typically
recommendation
for
on proper equipment.
groundwater
ALS
wells.
recommends the use of Tyvek suits and
Talking
face
about
masks
Tyvek suits.
to reduce
We're going to get to the
risks
meat of this
of
here in
sample
just a second.
contamination. Before sample collection, make sure to have 2 samplers available. The clean hands sampler is responsible
So you've got
for
clean
collection
hands
of
and
the
dirty
sample,
hands.
while the dirty hand sampler is responsible for labeling and setup. To begin sampling, open the outer bag holding the sampling kit.
And you can see dirty hands opens the outer kit, clean hands reaches in, removes the bottles.
Open the inner bag to remove the
Clean
sample
hands
container.
is the only one that touches the
If
actual
possible,
sample bottles.
submerge the sample container.
Submerges the bottles,
Rinse the
rinses
container
them 3 times.
using the sample to be collected. Please note that this process should be done as quickly as possible to avoid atmospheric contamination. After rinsing is completed,
And after the
submerge
rinse,
container
you
and fill
try
the
to cap
folder with
the
sample.
sample bottle under the
Cap the
surface.
container and place it back into the inner bag. Open the outer Ziploc bag, place the inner bag containing the sample, seal the outer bag, and place it back in the cooler. Follow the same procedure using the containers and Ziploc bags included in the duplicate kit. For sampling of the field blank, do not rinse the containers. Use the supplied water as the sample.
Okay, so I'm going to go ahead and stop that, and then we'll just move on since nobody can hear that. But you get the gist of it. It's clean hands, dirty hands, and the clean hands person is the only one that touches the actual sample containers. Dirty hands handles everything else. If there was a sampling device, dirty hands would be the person actually either turning on a pump or lowering a sampling device, and the clean hands person would be handling the bottles. So, all right, so moving on, summarizing the method here. The 1669 method, which is an EPA method that was written in 1996 or promulgated in 1996. It's a performance-based method, and it is a guidance document. If you can show that your method is, the method that you're doing is clean via method blanks and data reproducibility from field duplicates, the method is intended for collection of and filtration of ambient water samples for determination of total and dissolved metals and supporting the monitoring and permitting programs administered under the Clean Water Act. It's also not just for mercury, it's for any metals you want to do trace and ultra trace samples on. And obviously you've got a person who's going to be your clean person and somebody who's going to be your dirty person. And the dirty hands person stays away from the sample. In setting up for low-level, we're going to focus on low-level mercury, so I'm going to just refer to that. Prior to any field activities, all the sampling equipment, containers, and any materials which come in contact with the samples must be verified clean. Usually, if you're reusing any equipment, you've gone through some cleaning process at the lab, there's been a rinse-out process, and then the sample, whatever you've rinsed, that material has gone through the lab, and the rinse-out has been checked via the 1631 process and made sure that there's no mercury detected from the rinse-out. Again, we're talking about clean hands and dirty hands, and the clean hands person is the person in contact with sample bottle and transfer, dirty hands preparation of the sampling device, operation of equipment, and any other duties not involving the direct contact with the sample.
Hey, Les.
Yeah.
Hey, we have a question from Gerald. He says, please define ultra trace.
Ultra trace would be, I mean, I guess by definition would be anything in which you're going beyond the typical reporting limits, method detection limits that you would normally be looking for. For mercury, for example, you're looking at 0.2 nanograms as opposed to 0.2 parts per billion, 100 times lower, 1,000 times lower. And again, since we're focusing on mercury, that's an example. We've also done this method for other metals in sampling in the steel industry, which is kind of silly because there's metals everywhere, but they've asked us to perform 1669 sampling for basically for a whole suite of priority pollutant metals in the steel industry, and I know they do it for other industries as well. So anything that you're looking for ultra low levels, you can do the method for. I hope that answers your question. Since we don't deal with the high-res ICP mass specs, which is probably where that would be really would come into play. So anyway, the method summary. The method actually calls for field blanks and field duplicates to be collected at each site. That's the original method. The things have evolved a little bit, and not every person monitoring or every entity monitoring does blanks and duplicates for each site. Site is kind of a definition. Does that mean the entire plant? If some plants have, one of our customers has 20 outfalls, and does that mean each of the 20 has a blank and a duplicate? In that case, they do. Other ones, and the site is defined as the plant. Other facilities have 3 or 4 outfalls, and they define their site as their site. So they pick one and do a blank and a field duplicate for the site. But there has to be a field blank and a duplicate, at minimum 1 every 10. So there is some process to define to look at how your sampling process is going on in the field to make sure that you're staying clean. The sample collection techniques vary widely as made necessary by the access of other ambient conditions. And we'll look at that in a little bit here. Dissolved metals are filtered through 0.45 micron filters. Filter blanks need to be processed to make sure that the filtering apparatus is clean. Sometimes you will get a certificate from a manufacturer to show that they're clean to 0.2. Most cases, you don't even get that for the bottles, so it's probably not going to happen for the filters either. Sample preservation may be done in the field or in the lab within 48 hours. This is a summary, a real quick snapshot of how to take low-level mercury samples. I'm not going to hold this up here, but this procedure came from our Middletown lab, and typically the labs and the ones at the ALS facilities, you'll get a little one-page snapshot of, okay, this is what you do, and it basically is the same process as you saw in that video, and it's very it's very straightforward. You follow steps 1 through 9, repeat steps 1 through 7 for duplicates, etc., etc. So it looks pretty easy, and so everybody's ready to go. And you think, oh, you might want to wait a second, because there's a lot of considerations that need to be addressed before you just jump out there. If you're working on any type of heavy industrial side, of course, you may want to look at, is there a QAP that needs to be reviewed or signed up? Is there a JHSA that needs to be completed? Are there site-specific sample plans, site-specific equipment needed? If those questions are answered, you might want to consider any other things that we're going to take a look at here in terms of two areas here that that are probably the big areas that I think of when I'm sending out bottles or going to the site. The first thing is the site-specific considerations. I look at three different situations here: potable water sampling, either residential, commercial, municipal; groundwater sampling, where you look at the site; the purge method and requirements; equipment reuse or decon; and wastewater sampling. Again, site conditions and sampling process may vary widely with wastewater sampling. For potable water, it's usually pretty straightforward. They're really, unless you're in a really unusual situation, you're primarily opening a tap. Fluoridation does not affect low-level mercury analysis, so there's usually not too much to take into account. The groundwater.
Hey, Les.
Yeah.
I got a quick question from Roseanne. Why would you rinse a certified clean bottle from the lab before collecting the sample?
That's a darn good question, Jared. And it is in the procedure. The procedure also alludes to sending the bottles out full with certified clean water and dumping the water out and then filling it with the sample. You know, I personally, you know, there's situations where, and I'll get to this in a few minutes here, that rinsing the bottles is not really possible. And so let me just jump back to, we'll address that in just a minute here. I guess the answer to that is, you know, my personal view on that is I wouldn't. I think in some situations you run the risk of more contamination than the process is worth. If the bottles are clean, the bottles are clean. I don't think it really hurts anything, but I don't really understand the necessity for it. So how's that for an answer? So back here, groundwater samples may require filtration. They're the ones that would most likely require filtration. You can do the filtration in the field, or they need to be done within 24 hours at the lab. It could be tricky if you have to ship bottles because you have a 24-hour window that specifies in the method 24 hours for filtration. So that's a consideration when you are sending sample kits out. Everybody needs to be aware of that. Tubing for groundwater sampling is another. It gets a little bit tricky. Peristaltic pump, if you're using a peristaltic pump to sample, that specifies the SEBS resin tubing for the suction pump, for the suction line going through the pump, with the suction line being your fluoropolymer or Teflon. The bladder pumps, usually they're stainless steel, with the bladders being Teflon. It's usually you end up having to decon the bladder pumps between each well. Not usually, I guess all the time you would have to do that. And the bladders typically can be replaced between each well. But your optimum situation there is if you can use a peristaltic pump where the tubing can be replaced after each well. We haven't done a whole lot of groundwater low-level mercury sampling. It also alludes to in the procedure, the state of Michigan has a really nice SOP for groundwater sampling for low-level mercury, and their process is rinsing with tap water with 3 rinses, and then they rinse with certified clean DI water, and then they take a low concentration acid rinse, and then they do another certified clean water rinse if you're going to reuse the material, which is probably a good process as long as your water is pretty clean. You know, if you get into a situation where you've got water that's oily or have some other bad players in there, it might not really work out that well. But the handling of all the tubing and all, if you've got deep wells, for the bladder pumps, you've also got an airline going downhole. All that material needs to be clean when it gets into the water, so it gets a little tricky. Obviously, there you go. If you're reusing the pumps, you need a documented cleaning process, and there needs to be equipment blanks with rinses to make sure that everything is clean. And you need to follow your SOP or your work-specific plans. For wastewater, there's a lot of different scenarios for that. And I will say in 30 years, I've never been asked to collect samples from a fish tank, which is what the video that we have. I'm not poking at the video, but that is the perfect scenario for collecting 1669 and 1631 samples from. It's the perfect situation, and there are a few like that where you just go to open a faucet. Wastewater, some of the larger wastewater plants have sample ports that they just open a valve and you let the valve purge, and you take it from there. And so we'll look at a few of those right now, and this kind of goes back to the question of why would you rinse the bottle? Can you rinse the bottle? Well, this is one that's not a fish tank, but it's close to a fish tank. So could I rinse the bottle here? Yes. This is about a 35-gallon tank where the effluent comes out of that pipe into the tank. It's easily accessible, and you could very easily rinse the containers if you wanted to. Again, I don't really see the need. I think it's more up to what if there's a site-specific plan, and I don't think the methods really focuses on that 3 rinse process. So that's probably right there is about the ideal situation for this is an NPDES outfall or an NPDES discharge. That's about as good as it gets right there. This is another situation here. What they have here is you're looking down on essentially a waterfall where the water going over the weir is about 1 inch deep. So trying to get a sampling device to get 1 inch of water is difficult. This bucket that's hanging there is a stainless steel bucket that has hooks that they've designed. It hangs, you can't really see it there very well, but it hangs on the weir and it fills the bucket and overflows, which allows you to get into the bucket with either there's tubing there and you can pump it if you've got the proper tubing and the proper setup, or you can take a grab sample using a setup like similar to this where you've got a pole with a device and the certified clean bottle on the pole, which you can just lower down into the bucket and fill. So that's one scenario. Another situation, this next one is a manhole into a 78-inch concrete sewer. The outlet of the sewer is inaccessible. The exit velocity also exceeds about 5 feet per second, so it's moving out of there pretty good. It's about a 60 million gallon per day discharge. But the NPDES permit requires you to sample at the upstream manhole. There's the manhole covered. There's the manhole open. So, going in there with 40 mil vials is really not an option, obviously. Also, trying to reach that with the device, with the bottle on the pole is not an option. This particular discharge is hard to sample because everything glass going down there is likely to get broken unless you take some measures. This is the discharge point. That's about 25 feet down. The reason they move up to the manhole to take the sample is that the discharge is commingled with the receiving string down there, and you need to have you need to have the sample before it's commingled. So what they've done in this case is they have this sampling device, and we put our certified clean bottle into this device which is connected with a Teflon coated row, and the whole unit goes into the hole, and the PVC container takes the brunt of the battle. And if the gods are with us, the bottle comes back full and not broken. It's tricky, and it's, this is a situation where you don't, you definitely don't go for 3 rinses. You're happy to get a full bottle. And it's, this is a situation obviously where you're not using 40 ml vials. So that's just that's a scenario where when I look at the bottles going out, if a client has this situation, I wonder how they're getting filled. This is another one where you've got a lagoon, and at the bottom end there on the lower right-hand corner, there's a weir. The lagoon is overflowing the weir there. This is a reach of about 20 feet. It's a little less than 20 feet because you can reach it with the device with the bottle on it. There's a bunch of carp in there, so you have to watch the carp. And again, you just submerge the bottle. And when we do this one, I do not do multiple rinses here. You just trying to avoid all the material there's a lot of weeds, and again, the fish are down there. When you stick it down on the water, the fish want to see what's going on. And so there's no 3 rinses on that one either. The other thing, and this is kind of where I want to wrap up here, I keep mentioning this, when we send out bottles, I know what we send from Holland. I've asked the labs in ALS that do low-level mercury, Rochester, New York, Middletown, PA, Holland, and Kelso, Washington, and I kind of queried everybody and wanted to see what our bottle kits look like, and and I know that we don't have the same kits, so and I don't know which lab anybody would in particular use, but this particular sample bottle is from Rochester. It's O2SI is the manufacturer. They sell certified clean bottles, double bagged with gloves, and basically they come into the lab in a case, and the lab can pull the bag out, and we could send them to you. We put them in a bubble wrap and send them to you. Holland also uses these. Holland uses those in conjunction with the 40 ml vials. The bottle there from Holland has your blank water, so you would pour the blank water into the 40 ml vials. So we use a combination of those two. Let me go back there just 1 second. So you would end up with 3 sets of 40 ml vials for a duplicate and a field blank. The field blank being poured off that bottle, and the other 2 sets would be the sample and the field duplicate. If you're using just the bottles without the 40 ml vials, you would end up usually with 2 of the bottles and 1 full bottle with the water. You transfer the water into one of the other bottles, and we use the bottle with water that came with water as a sample bottle. Those bottles are very expensive, which is why we try to use the 40 ml vials. There's also an advantage in the lab because we don't have to disturb the bottles, the 40 ml vials. If we leave them sealed, we don't have to touch them for 30 days. If you use the 500 ml bottles, they have to be preserved. So we have to open them and preserve them. In the 40 ml vials, we don't have to do anything to them. So all these variations, they have to be certified clean to 0.2 nanograms. This is a combination of bottle kits that come out of Kelso. And this is a set of bottles that come out of Middletown. So you can have any of these combinations. So if you see any of these, you know that we're all good. This particular set has a field filtration apparatus in it, and it also has field preservation in this vial off to the left. So you also have that as an option. I believe this might come out of Waterloo. I'm not sure. So there are a lot of, when you request low-level mercury kits, you will see a lot of variation. You need to make sure what you're getting. If you have questions, make sure you talk to your project manager about what you've got. And I would say, let me just wrap this up. There are a couple reference documents that really, they do a lot better job than I do explaining this from a technical standpoint. Again, the 1669 method is performance-based. I look at it when I go out in the field and I look at how we're doing. I look at our field blanks, I look at our duplicates. If our field blanks and duplicates are good, then I think we're doing a good job. The Michigan document is a really good document for low-level mercury sampling in groundwater. If you have any particular projects where you might have to do that or provide equipment for that. So at that point, that's really all I have. The one thing I did want to wrap up, though, I want to go back for just one thing here. When we send these bottle kits out, we send them out and we expect that the person receiving these bottles knows what to do with them. The question that's always in my mind is, how are these bottles getting filled? When I'm going out there, I'm taking a certified clean bottle, dipping that bottle in whatever water, dipping it with a certified clean instrument, whether it's that dipper or a pump, or I'm able to put my hand on it and fill it. I went onto a site that we had not been sampling. There was basically an open ditch leading to an influent to a lagoon, and in this open ditch they had a pipe with a plastic bottle that had been cut in half and zip tied onto this pipe, and it had obviously been there for some length of time. I'm talking years, and they were using that to reach out into the stream to fill the low-level mercury vials. So in my head, okay, I'm thinking we have these bottles that we take great care to clean, and then we take this dirty piece of equipment that's been sitting out there outside and for we don't know how long, and they then fill the bottles from that. That's not the intent of this. The intent of it is to get the water directly into the bottle the best way you can. You saw some situations there where you can't do that, but you don't want to get, you want to make sure whatever vessel you're using to fill the bottles is also clean. So that's kind of one of the things, and I don't know how everybody does it, and I don't necessarily think that we necessarily ask. I think we sometimes just expect everybody to know, and that's the main thing is to make sure you ask if you're not sure. And really, that's all I have. So I'm happy to answer any questions I can.
Thanks, Les.
There you go.
Thank you, Les. I do have a question from Arjun. He says, what would you recommend for decon in the field? We currently use 10% Equinox solution with the triple rinse of DI water.
That is probably a good start. I mean, if you can use some dilute acid, that would probably be dilute hydrochloric. It's always tricky doing that in the field and also having some certified clean water. I'm assuming there's a certified clean rinse after the Equinox. But if you can do an acid rinse, that would be helpful. It's tricky dealing with acid in the field. Obviously, you have to have a way to dispose of it and make sure it's not ending up in the environment.
Great, thanks. And Gerald, I see you have your hand raised. I'll unmute you real quick. Did you have something else? Or was that from before?
That was from before.
All right, thanks, Gerald. Any other questions? Okay. All right. Well, thank you all for joining us today, and Les, thank you. Um, I just want to remind everybody that we do record all of these webinar Wednesdays. This has been recorded, and we will post it on our YouTube channel. So go to YouTube and search ALS Limited to find our channel, and then click on the North America playlist. And there you will find a wide range of video resources, including the sample instruction video that Les showed earlier. That's on there as well, along with past Webinar Wednesday presentations. Also, please follow our showcase page on LinkedIn, as well as other various forms of social media. We always post links to future webinars and other valuable resources. I also want to mention that somebody from our Calgary, Canada location is scheduled to do a webinar Wednesday next week about low-level mercury analysis. Les talked more about the sampling side of things. They're going to talk a little bit about the analysis methodology of it. And so keep an eye out for a link to register for that coming. You'll see that posted on our LinkedIn page later this week. And with that, if there aren't any other questions, I don't see any more. I think that'll do it. Les, thanks so much for your time, and thank you everyone for joining. Have a good day.